Hey, welcome back. So, today we're going to talk about sprite collisions, so sprites colliding with another sprite. And we're going to talk about actions. So, if we have enemies in our game, we want them to perform certain actions. So we're going to take a look at that as well. But before we do that, I'm going to show you something else that I haven't talked about. So this is something that's built into the Commodore 64. So let's take a look at an example here. So let me start by running this code. So this is something we have seen before. It's not really new. I'm just displaying a sprite here at a certain position. I have set him up with multicolor and I have the right sprite graphics for him. So nothing special, right? Well, here's a thing I haven't told you. There are two memory addresses in the Commodore 64 that allows us to stretch a sprite, so it can be double the width, can have double the width and double the height. So we can stretch them in both directions. So if we want to have a sprite that's twice as big as normal, we can stretch them out. So two memory addresses keeps track of that. You have D1017, that's the address for double height. And this works the same way as the one we've seen with multicolor and the one address for enabling sprites, which means that each of the bits is for a certain sprite. So just like with the other ones, we start here at bit 0 for sprite 0. So if I put a 1 here, then this sprite is going to be double as it's going to be have the double width. So let me just set 1 for that now. Let's see how it looks. So you see, now he's stretched out like that. He's double as wide as he was before. What if I put a 1 for the height memory addresses as well? So I put a 1 here at bit 1, because as I said, this follows the sprite numbers. So now I have a 1 on bit 0 for both double height and double width. So if I do that, what is he going to look like now? There you go. So now he's twice as big as normal, just by changing these memory addresses. So there's 1 for double width and 1 for double height. So in case you need those. Now obviously the pixels are stretched as well, so he will be the pixels will be extra big if you do it this way. But it's an option if you want to have a huge sprite like this without combining several smaller sprites. So I just wanted to show you that because we haven't talked about that before. So now you know about those two memory addresses. We're talking about D1017 for double height, D1001D for double width. Alright, so now let's talk about sprite collisions. So here I have a picture of a little guy. This is from a Nintendo game that I made a while back. So how can we check if one sprite collides with another sprite? Well, there are several techniques for that. But a very common one is something called a hitbox or a bounding box. So if you see this area that I have marked up with red lines like this box in here is this little guy's bounding box or hitbox, which means that this area is what's actually checking for collisions. Which means that if he collides with a monster or a hazard of some kind with his hand here, for example, or his hand on the other side with his sword, if those are colliding with something, nothing's going to happen. But the moment that the enemy or projectile or whatever is going to hurt him, whatever collides with this area, then that's going to trigger a collision. So the concept is not hard to understand, right? We understand that in this box, that's the area that's actually checking for collisions. Now the hard part is, how can we program that into assembly language? I mean, we can't draw a square in assembly language like that, which means we have to once again give some sort of meaning to this into our code. So in very basic terms, what this means is that his hitbox area here, it needs to have, for the horizontal, he needs to have a starting position and an end position, where for horizontal, so the X position, where does it start, where does it stop? Same thing for vertical, where does it start, where does it stop? So by combining those four values, we can say that whatever's in between here, so whenever there's a collision between this number and this number, that's going to be a collision. Same thing here. So somehow we need to make a system that can handle that. But let's also just acknowledge that I mentioned this before. There is a memory address in the Commodore 64 that checks for sprite collisions. So something that's built into the Commodore 64 collision detection. So every sprite has that. It checks for collision with another sprite or collision with a background. Now it requires a little bit of setup, but there is a memory address for that. So we have this one, Sprite Collision Register. And like we saw before, there's 1 bit for every sprite. Now the problem by using this memory address, well, it's not a problem, but we need to be aware of the fact that if we use this memory address, it just says this sprite collided with another sprite. So we don't know what the other sprite was or anything like that. We just know that our sprite collided with another sprite. So that means that if you want to use this memory address, you need to program some additional logic. So I mean, if you're programming a shoot 'em up game where everything kills you, if you collide with another sprite, it kills you. If you collide with a background, it kills you, and so on. So if you're going to use it very simple like that, then I guess this would be okay. But it's not a great collision detection system on its own like that. So that's why we're not going to be using this one. Now the next address, as you can see, is the one for sprite background collision. So D1001E, that's sprite collision between sprites. D1001F, that's sprite background collision. And both of those just have a bit that says, yeah, this sprite collided with another sprite, or yeah, this sprite collided with the background. So the addresses are there, but like I said, you probably will need to program some additional logic if you want to use those. So we're not going to be using those. So let's take a look at a simple example for just checking collision between two sprites. And we're going to take a look at an example that we program ourselves. We're going to be using that bounding box technique. So we're going to be looking at an example from codebase64.org. It's an example by a guy called Richard Bayliss. He has made a software sprite collision example here. So I have taken this example and I have extended it a little bit with joystick input and some small things like that. So let's look at that now. Okay, so here we have my example code. And I made a little sprite graphic that we can see over here. So we were talking about bounding box before. Bounding box, hitbox, whatever you want to call it. So the question was, how can we make that in our code? Well, here in this example code, we start by making a few labels. We have x size 1, x size 2, y size 1, and y size 2. Now, basically what these are the my definition of my bounding box. So what I'm saying here, x size 1, that's actually where the hitbox is going to start on my sprite. And when I say 0 here, that's at the very left edge of the sprite. When I say x size 224, that's on the very right side of my sprite. Because remember, a sprite is 24 pixels wide, 21 pixels tall. So that means that when we're looking at the y size 1 here, 0, then that's the very top. Y size 2, 21, that's the very bottom. In other words, this whole thing is a hitbox, or in other words, my sprite here, the entire sprite is a hitbox. We could have made a small one here in the middle, for example. But in this case, I just decided to make a hitbox that covers the whole sprite. Alright, so those were the constants here. And I have some more constants for joystick input. We've seen that sort of thing before. Then I get down to game setup down here. And it's nothing special really. I just set up two sprites. Sprite 0, that's going to be me as a player, I can control. And Sprite 1, that's going to be a sprite I'm going to call it the enemy. It's just going to be there, and I can collide with that sprite. So what I'm doing here is just setting up two sprites. Setting Sprite 1, Sprite 0, and Sprite 1. And just plotting them in the X and Y position. Now, I'm not using raster interrupts here, but I'm still using this technique with Sprite X and Sprite Y tables and updating the actual memory positions somewhere else. In this case, I have a delay loop and I just update the positions in there. But anyway, I'm setting up Sprite 0 and Sprite 1. They have their own X and Y position. I set Sprite 0, color of Sprite 0 to white, the color of Sprite 1 to green. And then I say use the same sprite pointer index for both sprites, which means that both sprites are gonna look like this, like we have here on the right. So I load that number and save that into both of the sprites' respective sprite pointer addresses. And then I just enable both sprites, right? We have enable Sprite 0, Sprite 1. We've seen that before. And of course, I clear the screen. So then we get down to my game loop here. And it's really simple. I just run my delay loop, where I delay and also update the sprite positions in memory. But then I read my joystick input, which also is going to move the sprite. But here I have check collision, which is important for us right now. So what happens in my check collision routine? Well, let's start here at the top. So I start by loading X with 0. That means sprite 0. Then I say load A with sprite X position. So give me the X position now for sprite 0. Then I say subtract with X size 1. X size 1, that was the constant we had here at the top. So where I actually specified the hitbox. So I say load the X position and subtract what I defined as the hitbox left. When I subtract, that means that this hitbox could be larger than the sprite itself. So when I subtract from the X position, then we would move, outside of the sprite graphics. But since I have 0 here now, you're gonna end up here right on the left edge. This, of course, is something you can play around with. You could have add or subtract, whatever. But I'm just gonna make it simple. I'm gonna say that the whole thing is the hitbox. So I'm subtracting X size 1, which is 0. So just this, because remember, X and Y position of a sprite is always the top left corner of the sprite. That's where you start counting. So when we say the X position, that's from here. Y position, that's from the top, like that. So right now I'm here. And then I say add X size 2. That was 24. So that brings us over here on the right edge. So basically I'm saying that my hitbox goes from here on all the way on the right side. And I do the same thing for the Y position. Load Y position, subtract Y size 1, that was 0. So I'm just gonna stay up here. Again, I could have subtracted with a number which would have gone beyond the sprite graphics. But another important thing now, I forgot. I'm storing all of these things into variables. So I have 4 variables. I have 4 constants. Those constants define the start and end position, left and right, top and bottom of the hitbox. But I store, take the X position, add and subtract those things, but I store the results in these variables. Collision X1, collision X2, collision Y1, collision Y2. So after subtracting hitbox values and adding hitbox values, then I end up with 4 variables, which is in practice my hitbox. So now I have that set up. It's really simple. You can see it's just loading the X and Y position and adding and subtracting offsets here. So this is of course something you have to play around with for your game for it to make sense. But with those 4 values, I need to use those to compare to something else, because this was sprite 0. Then we get down here. I'm loading X with 1 now. That's sprite 1. What do I do here? Well, I'm loading the X position for sprite 1 now. Okay. So what do I do here now? Add with 12. Where does that number come from? Well, here's the thing. My player sprite has a hitbox now. The enemy, or the other sprite, does not have a hitbox like that in my example here. So what I say is that the other sprite is just, I'm just going to check collision on that sprite, and at the very center, in the middle of the sprite. That's the only place I check in collision for that sprite. So my player has a hitbox, this other guy just have a little spot in the middle. So those are the things that we are checking collision between. So I'm writing 12 here, 12 pixels, that's halfway across the sprite. So here I'm saying load the X position of sprite 1, add 12, alright, so then we get here in the middle of the sprite. Compare with collision X1. Now collision X1, that's the left of our bounding box for the player. So we are comparing the middle of the enemy with the left of our bounding box, player bounding box. BCC, branch if carry clear. That's branch if less than. BCC, branch if less than. So if the center of the enemy here is less than, so it's if that's to the left, it's to the left of our player, then we branch to not hit. Then there was not a collision. But if it was not to the left of our player, then we say compare with collision x2, which was the right side of our bounding box. We're comparing with that, and BCS, branch if carry set, that's branch if equal or greater than. So we say here, let's say greater than in this example. So we're comparing with collision 2. So if this enemy is to the right of the right edge of the bounding box, it's to the right of that, then it's not hit. So it's a little hard to explain these sort of things, but hopefully it makes sense. Basically, we're comparing if the enemy is to the left or to the right of this bounding box that we have defined. But that was the X position. So here we are checking the Y position of our enemy. Remember, this is a sprite 1. But this time I said add 10. Now, a sprite is 21 pixels tall. So divide that by 2. It's not really 10 because but we don't have decimal numbers here. So I'm just going to say 10 because that's more or less half the sprite. So 12, 10, that's going to be just about the center of the enemy sprite. But again, we do the same thing. We load the Y position of the enemy, add this little offset, and then we say compare with Y1. Now, that's the player, the top of the player bounding box. If branch if carry clear, so if this enemy is above the top of the bounding box, then there's no hit. We compare compare the center here to the bottom of the player bounding box. Branch if carry set, so branch if greater than. If the enemy is below the hitbox, then it's not hit. But if none of these things are true, we get down here and then we have hit, which is a collision. That means that it was the center of the enemy sprite is inside that bounding box somehow. Because we've done the check. Is it to the left of the bounding box? Is the enemy to the left of the player's bounding box? Is the enemy to the right of the player bounding box? Is the enemy on the or above the player bounding box? Is the enemy below the player bounding box? We've done all those checks. If none of those are the case, then it must mean that the center of the enemy is inside the player bounding box. Which brings us here. What happens if though they collide? I just increase the border color. And I say I'm done. So if we collide, the border color is going to change. If we don't collide, then I reset the border color to light blue. So yeah, then we have the joystick routine and my delay loop. So nothing we haven't seen before actually. So I'm just going to run this now. And let's see how this works. So here is my player sprite. Here is the enemy sprite. Now, like I said, I programmed in joystick controls so I can move my sprite 0 around like that. I'm gonna try to collide with this green guy. That's the enemy. So you could see that when I'm colliding with him, the screen border is changing color. So that means that now we actually have Sprite Collision system. But let's also look at this in a visual way. So I said that for my player sprite, I'm defining the bounding box, hitbox, whatever. I'm defining that as, it's gonna fill my entire sprite graphics, right? But that's the player sprite. The enemy sprite, we only check collision on the center on that one, right here. So basically that means that if we look at my player now, I'm gonna collide just a little bit with this enemy. You see, I'm colliding a little bit here on the side, nothing's happening. Because we're only checking collision on the center of this enemy guy. So I'm gonna try from the top, nothing's happening. From the left there, nothing's happening. Same from the bottom. But when my the right edge of my player reaches the center, let's see if we can see that. So when the right edge of my player reaches the center of this enemy, then the collision happens. Same with the bottom and the left here. So this is some very basic collision routine, and it might work out just fine in your game. We could have made a bounding box for the enemy as well. Now, the thing we need to keep in mind, we haven't really talked about this, is performance. How fast do we want the code to run? And of course, we want it to run reasonably fast. We don't want our game to slow down. So, like I said, we haven't talked about this, but we have to remember that every time we use a mnemonic like this, well, first of all, we have mentioned that every time we use one of these, it takes up a little space in memory. Usually, one of these mnemonics takes 2 or 3 bytes in memory. So, 2 or 3 bytes at average for every time we use a mnemonic like this. So that's the first thing we need to remember. The more code we write, the more space we're going to take up in memory. But every time we write a mnemonic, that also takes a little bit of time for the CPU to perform. So for every one of these we write, it's going to take just a little bit longer to perform. So if we write 5,000 mnemonics for some kind of advanced collision check, that's probably going to be a little bit slow. But if we write a short, effective routine like this, then it's going to run reasonably fast. So that's something also we have to keep in mind as programmers. Need to keep all of these things in mind, but probably these sort of things is something you have to practice just to experience what's fast and what's slow. But anyway, the point is that with my my collision routine now, by just having a bounding box for the player, or I'm actually just checking collision for the player, just by doing that, it makes my code pretty effective. Works out really nice. I don't need to check collision for the enemy. I don't need to check, hey wait, did the enemy collide with the player? I don't need to check that. I just check if the player, so I just check the other way around. Did the player collide with an enemy? So I'm just gonna use collision for my player here. The enemies, don't worry too much about them, but I need to check collision for my player. That's very important. And if I had a gun that could shoot a bullet, and that bullet was a sprite, then I would have to check collision for that sprite as well. but at least for the player, we really need to check collision for that. Yeah. So this, as you can see, is just a simple example of sprite collision. How we can program a system for bounding boxes. So now I want to show you something that I forgot in the last episode. In the last episode we looked at sprite animations and how that happens. But I didn't show you where I actually set what animation type to use. So now I'm going to show you my input library where I read the joystick input. And here I say, first of all, I'll set the sprite to sprite 0, which is the player. Load X with 0. Then I do all these checks that we have seen before. And you can see that some of these have the animate sprite macro. And that's where I specify what animation type to use. So in this case it was idle. I check the direction he's facing and I'm going to set him idle left or right if I'm not moving the joystick. And if we go down here, I press up on my joystick, then I have this jump code, and again I check directions and I set the jump animation. So either if he's facing right, I have the jump animation right, left, jump animation left. And down here, when I'm holding left and right, I'm setting the animation type to player walk left or player walk right, whatever, and the speed of the animation. So I just wanted to show you where I set those animation types. That's here in the read joystick. But let's get back to this collision thing and just finish up that part. So I have my sprite library. We already seen that. It's pretty big, a lot of code in there. And I also have something for create a sprite, so activate a sprite, deactivate a sprite. We're not going to be looking at that right now. But we know about this handle sprites routine, which is pretty big. There's a lot of stuff happening in here. Now we've seen sprite movement. And last time we looked at sprite animation. And remember, this whole thing is just a big loop. So it's going to loop 8 times. So 8 times because we have 8 sprites. So every sprite is going to have their own turn in this loop. And that loop handles, like I said, animation, movement, stuff like that. And in just a second, we're going to look at this sprite action. But first, I just wanted to show you that here we have sprite movement, all that stuff. But if I go further down here, then there's actually this part, sprite collision. So here is where I check, in my game now, here is where I check collision with other sprites. Now I haven't shown you this, but I have a table called sprite flags. That's actually a table in just like my other sprite tables, 8 entries, so every sprite has their own byte. And I have every one of those bits in that byte means something. And one of those bits is to say if this sprite is a player or not. So basically what that means in this case is that I check when I get through the loop here and I get to this point, I say, is this sprite a player or not? If it is a player, then we do this sprite collision check. If it's not a player, then we skip this whole sprite collision check. Because like I said, I'm only going to check collisions for the player. So that's what I do here, and then I basically do what we did in the example. Check the collision here, and I have once again I have something in the reaction library. So if there's a sprite collision, I go to the reaction library and perform something. But I just wanted to show you where I placed it in the code. So most of this logic actually happens in my sprite library, in the handle sprite routine there. So if I go to my main, my gamecode.asm here for this whole game, and we go down to my game loop, you see that it's pretty simple. I just basically do two things here: read joystick input and handle sprites. That's my game loop. So as you can see, most of the logic is actually happening in my handle sprites routine. So if we go back to the sprite library now, and if we go down to where we have our handle sprites subroutine, the first thing that happens in here, well, first thing is we load x with 0 because we know that this is a big loop, right? But the first thing in the loop is something called handle sprite action. What's that all about? Well, in our game, we're probably going to have some enemies or some objects moving around doing their own little thing. Now, how can we make all of these things happen? We know that we can control a sprite, and that's kind of cool, but that's not a real game, right? Just controlling a little guy on screen. So we need to have other things going on at the same time. So what I have done here is I made something called Sprite Action. I even have an action library. So the way this works is that inside my handle sprites loop, as you can see at the very top here, I start by again reading this sprite flags table, checking is this a player or not. If it's a player, then we skip this thing. If we don't want the player to go do his own thing, we want to control the player with our joystick. But if it's not the player, then we run the check sprite action number routine. So let's go to our action library now and see what's going on in there. So here in my action library, I have a few subroutines. I have this check sprite action number. So here we can see that there's even a table called Sprite Action, which has an entry for every sprite. So we start by checking, when we say X here, that's the active sprite number, because we keep track of what the sprite number is with our sprite loop or handle, our handle sprite loop in a sprite library. So by the time we get in here, we know that this is sprite 2 or sprite 3 or whatever it should be. So we load sprite action from there. Then we compare it. Now it says compare with 0 here. We know that we don't have to write compare with 0, but I wrote it anyway to make it more easier to read. So is this sprite action 0? Yes or no? If it is, then we jump to sprite action 0. If it's not, then we go down here, check is this sprite action 1, is this sprite action 2, and so on. So if we jump down here to sprite action 0, sprite action 0, that's no action. That's a default one, right? So nothing's gonna happen if the sprite action is set to 0. If the sprite action if the sprite action was 1, then that's something called move. This is for the monster in my game. So monster is going to move towards the player. How do I do that? That sounds a little advanced, right? Well, it's not really. It's just really simple. I just check the X position of the player and I compare that with the X position of the monster sprite. So here we can see that I'm using the BCS again, branch of carry set. So if the monster position, for example, is that bigger than the player's X position, So I'm checking if we are on the left or the right side of the player. Just checking the X position like that. If it is, then we move left or right based on if we are on the left or right side of the player. The monster moves left or right based on that. And I also have something here, branch if equal. So if the X position of the player and the X position of the monster is the same, let's say they're standing on two different platforms, but the player is on a platform above the monster, but the X positions are the same. Then I have something for the monster here that says monster confused. So what happens here, I'm clearing the directions, all directions, which means that he's going to stop. The monster is going to stop moving. And then I'm just animating something, an animation type called monster confused with this animation speed. But if he's on the left or the right side, then he's going to move in a certain direction and he's going to have a specific animation type. Then down here, my Sprite Action 2, that's just an animation for a spinning coin. So anyway, the point here is that I have this system where I perform some kind of action in here, and since this is a subroutine, then of course when that action is done, we return to here. So for example, if the action was move left, we set the direction to left in our action library. Then when we get here, the next thing here has to do with sprite movement. So if we set the direction to left in the action, we get down here, we check directions. If it's left, then that sprite is going to move left. So I'm just trying to show you how these things connect. Like I said before, now we see more and more that things are starting to connect quite a lot. And we need to have different kind of systems to handle different things, not just joystick input and sprite movement, but like in this case, we need to have a system for certain actions because we want something to happen. So hopefully you can see that but just like I said before, making sense of things, making systems that make sense to us. For me, it made sense to have a system for actions there. And just by including that as part of the big sprite loop like that, I can make sure that I know that every sprite that needs this action routine is going to have their own turn in here, because this is a big loop. But like I said, the player skips this. Hopefully that made sense. So now let's take another look at the game. So I'm gonna start the game now, and let's see if we recognize some of the things we have seen before. So we've seen that we have done tile collisions, and we know how that works. We can see some examples of that right now. Same with animations. I'm holding left and I play the walk. I'm holding right and I'm holding right on the joystick and the walk right animation is playing. So we have that sort of thing. And when I reach the right edge of the screen, I quickly load another room and I reposition the sprite there. But here we have a little monster guy. He's coming towards us and I'm standing right above him, so we have the same X position now, and he changes to this confused state. He can't find me. But when I start walking to the right now, then he starts to follow me again, and he just continues to follow me. But if I do this, then we have the same X position again, and he goes to this confused state. So that's how that action system works. But let's see if the collision works Okay, let's go to the next screen now. So here I'm gonna collide with this guy. So I collided with the monster. I played a little animation of a sad player, and then I went back to this first screen. And now I'm going to try to collide with this spinning coin down there. Here's the spinning coin. I collided with the coin goes away, and I got 100 points here in my score. So here we see a few examples of Sprite Collision and Sprite Actions. How we can make some more interesting things happen in our code. Not just moving a sprite on the screen, but actually making this look more and more like a game. So that's actually it for today. So I hope this was clear, and I'm gonna leave the example code for the Sprite Collision test in the description, together with some other links. But that's it for this time, so I'll see you next time. Bye bye.